Okay, so part 10, problem number 1. The volume of the moon is given. We're supposed to find the circumference. Well, if we're given something, we should probably plug it into its formula. So we know that volume for a sphere is 4/3 pi times the radius cubed. If we take this volume and plug it in right here, then we get this. So if we want to get r by itself, we're going to have to get rid of 4/3 pi. So let's go ahead and just go straight to the decimals this time. And we will just divide both sides by 4/3 pi, just like this. 4/3 pi. That way the pi's and the 4/3 all cancel out. So let's just put all this in the calculator and see what happens. This is what I got when I put all of this into my calculator. So I've got r to the 3rd power. Now I need to know what the radius is by itself, so I can use that to find the circumference. In order to find the radius, I'm going to have to do the cube root of all of this. So basically I'm doing the cube root of both sides of this equation. Okay, so please remember that when you do the cube root on your calculator, you start by typing in the number 3. Then you hit second caret and it becomes a cube root. So we want the cube root of 126,203,0113. So this is what we get for the radius. I'm going to keep both decimal places here. So 1080.66. Alright, that's the radius. Now I can go ahead and find the circumference. The circumference is 2 pi times the radius. So the circumference should be 2 pi times 1080.66. So just put that in your calculator and that should be the answer. So I'm getting the circumference is 6,790. Okay, problem number 2. We're supposed to find the measure of angle ACE given the information shown in the diagram. Angle ACE is this angle that's way out, that's way out here. Alright, now my thought process is the only way I know to find an angle that's extending outside the circle like this is to use that formula, that the one that says that the angle is going to equal, arc minus arc divided by 2. Okay? We're using this formula. Angle equals arc minus arc divided by 2. Now, if this is the angle, then this is one of the arcs that I need. But this is the other arc that I need. Okay? So I've got one arc, but I'm missing an arc. So I'm going to have to go on a little journey to find this missing arc. Let's see what I have to work with. Well, I have this 84 degrees, and I know that these two are the same. So that's what I have to work with. Let's start with the 84 and see how far that takes me. Okay, looking at the 84 degrees, 84 degrees goes like this. Now, if I look at the arc that's captured by this 84 degree angle, okay, the 84 degree angle is going like this and like this. Okay, so the arc that's intercepted by this angle goes from EDB like that. Let me highlight it to make it clear. Okay, the arc that is associated with the 84-degree angle goes all the way around like this. So, of course I could get that arc by doubling the 84 degrees. So let's do that. If I double 84 degrees, I get 168. So 168. That's the measure of the yellow arc. Now, if I know that part of that yellow arc is 56, if I want to find the remaining part, I should be able to subtract, shouldn't I? So let's do that. Okay, so if I do, so to find this part of the arc that just goes from here to here, I should be able to do 168 minus the 56. So I'm putting that in my calculator. And I'm getting 112. Okay, so that angle is 112 degrees. So if that is 112 degrees, that means this is 112 degrees over here as well. Okay, so this is 112 degrees. So now I have the two arcs that I needed in order to use this formula. Okay. I've got this arc and I've got this arc. So let's go ahead and do the formula now. The angle should equal the big arc minus the small arc divided by 2. So 112 minus 56 divided by 2. So I just put that in my calculator and see what it is. Turns out to be 28. That is the measure of the angle. That's why the answer to this question is A. Alright, let's move on to problem number 3. A circular pizza with diameter 15 is cut into 8 equal slices. What is the area of a slice? Well, the area of a slice of pizza, that's the area of a sector. So I could probably do it that way. Diameter 15. Okay, let's draw a picture. Okay, so here's our pizza cut up into 8 equal slices. We know that the diameter here, let's see, the diameter is 15. Okay, so that means from here to here all the way across is 15. Well, that should easily tell us what the radius is. Figure out the radius real quick. Well, the radius is going to be just half of that. Okay, so the radius is 7.5. Alright, if I know that the radius is 7.5, then, and I see the answers are all decimals, so I'm happy with the decimals on this one. I could start by finding the area of the whole circle. You know, the whole pizza. Alright, the area of a circle is pi r squared. Okay, so the area of the whole pizza is going to be pi times 7.5 squared. Okay, so let's just put that in our calculator. Okay, so the whole pizza has an area of 176.71 square inches. So if that's the area of a whole pizza, what do you think it will take to get the area of a single slice? Alright, so I need the area of just one slice of pizza. Okay, well, since there are 8 slices that are equal, I should be able to simply take the total area and divide by 8. So the area of one slice should be 176.71 divided by 8. So just put that in your calculator. I got 22.09. Looking at my answers, that would round nicely to 22.1 square inches. So one slice, the answer is B. Okay, let's move on to number 4. Okay, this one is going to be a little more tricky. Do you remember when we used to have problems like this? A shape inside of a shape, and to find the shaded area we had to, our strategy was to take the outer shape minus the inner shape. So in this case, if we wanted to find the shaded area, we'd start with the area of the circle, and then we would subtract the area of the square. Remember that? It was pretty tough. Well, this problem is almost the same thing. Now, as I ask you to find the shaded area, I don't really want you to look at the entire circle when you're looking for this, you know, the shape inside of a shape. I want you just to focus your attention just on this part of the picture. Okay? Focus on the sector. Now, imagine that we could find the area of the sector, the whole sector here. That would include the shaded area. Now, imagine that we had the whole sector. If we took away the triangle, then that would just leave this little wedge right here, this little crescent. So that's going to be our strategy. Alright, our strategy is going to be the shaded area should equal the area of the sector minus the area of the triangle. Okay, that's going to be our strategy. So let's find the area of the sector, and then we'll find the area of the triangle, and then we will subtract. So let's start over here by finding the area of the sector. Okay, now to find the area of the sector, that's when we do part over whole is equal to part over whole. That's how we do area of a sector. We're told that the radius is 12, so we might need that. So let's see what we've got here. Okay, so area of a sector, part, alright, I'll call that A for my partial area, divided by whole. Now that's the whole area of the circle. So area of the whole circle is pi r squared, which in this case is pi times 12 squared. Alright, and that's going to equal part over whole degrees. So I would need partial degrees over whole degrees. Whole degrees are 360. Here's the key to the partial degrees. It's this part right here. Triangle OPQ is equilateral. And we've seen this many times. an equilateral triangle is always going to have 60-degree angles. All three angles are 60 degrees, so that means the partial degrees are 60. Okay, so this angle in here is 60 degrees, which means this arc is 60 degrees. Anyway, partial degrees, 60 over 360. So let's continue with that. So that's going to give me partial area over 144 pi is equal to 1/6. If I cross multiply, I'm going to get 6 times the partial area is equal to 144 pi. If I then divide both sides by 6, okay, divide by 6, that's going to give me the area is 24 pi. Okay, so that's one part. The area of the sector is 24 pi. Now I need to find the area of the triangle. So let's focus on that. Okay, I'm going to do that right in this area right here. Let's worry about the triangle. Alright, maybe it would be okay if I sort of moved this picture of the triangle over here so I can work on it more easily. So let's do that. Alright, so it's an equilateral triangle, so let's just copy it over here. So imagine that this triangle is this triangle. Don't forget the radius is 12. That makes you know, these sides of the triangle are like the radii. Okay, this is like the center of the circle, so radius, radius. Okay, so that's 12. Remember that we know that this is 60 degrees up here, and that's important because the first thing I'm going to do, as I've done many times in this review, is I'm going to split this triangle right down the middle. Okay, knowing that if I split the triangle like that, then what was 60 degrees will split up into 30 and 30, which means I have two 30, 60, 90 triangles. Okay, now I have the hypotenuse. If the hypotenuse is 12, that will tell me what the short leg is. The short leg is 6. If the short leg is 6, that should tell me what the long leg is. 6 radical 3. Now, that's important because in order to find the area of a triangle, the area of a triangle is, of course, 1/2 base times height. So we needed the base and we needed the height. Now the base is this, all the way from one side to the other. Alright, just like the other two sides of this equilateral triangle, this base is going to be 12. I mean, you see the 6, double it, or you can look at the existing 12s. The base is 12. But we also needed the height, which is why we did all this splitting business to find the height, which is 6 radical 3. So the area of this triangle becomes 1/2 12 times 6 radical 3. Okay, I really don't want any decimals yet, and I'm afraid if I type all of this into my calculator I'm going to get a decimal. So you should be able to do this in your head. Save the radical 3, okay? Half of 12 is 6. And then 6 times 6 is 36. So this should be 36 radical 3. If you were going to use a calculator, then you really should just type in the 1/2 times 12 times 6 part, and save the radical 3 so you don't just get a decimal. Looking over at the multiple choices, I see that they involve radicals and pi's, so it's important that I not get any decimals. So if I go ahead and take this and include that back in my formula, so I wanted the area of the sector and then minus the area of the triangle, which is 36 radical 3. Then that was going to be our strategy to find the shaded area. So this should be an exact form of our answer. And sure enough, if I look back at the multiple choices, what do you think I see right here? Okay, so B is the answer. 24 pi minus 36 radical 3. Okay, wow, that was pretty complicated. These problems are tough. I'm not going to kid you about that. Okay, let's look at problem number 5. Now, first of all, they're telling us that the diameter is 10. That means that the radius is 5. So let's keep that in the back of our mind. The radius is 5. Now they want to know what the circumference of a great circle of the sphere is. Do you remember what a great circle is? Remember, a great circle is a circle that went all the way around at the largest point of the sphere. Alright, if I passed a plane through at this intersection, it would go through the center of the sphere. It doesn't have to be horizontal. This would be a great circle if it sliced the sphere directly in half. This could be a great circle. Each of these would be great circles. Let's see. Is this a great circle? Nope. Too small. Is that a great circle? Yep, that goes right through the center. Of course, the most famous great circle is the equator, which divides the Earth itself into two hemispheres. So that's what a great circle is, like the equator. Anyway, so a great circle is just a circle. So if I want to find the circumference is going to be 2 pi times the radius, or I could just do pi times the diameter, since I was given the diameter in the first place. Circumference is 10 pi. Okay, so that's the answer to A. Let's go ahead and do B. The surface area of the sphere. We'll just use the formula. Surface area is 4 pi times the radius squared. The radius is 5. So put that in your calculator. You're going to get 100 pi. So that's the answer to B. Okay, what's the volume of the sphere? The volume, just use a formula. 4/3 pi times the radius cubed. Just put that in your calculator. I'm coming up with 500 pi over 3. So that's the volume of the sphere. If the diameter of the sphere is decreased by a factor of 10, how will it affect the circumference, the surface area, the volume? Well, this is like one of those problems that we did on the other review sheet, where we always do three things sort of together. We look at what happens to the length, we look at what happens to the area, and we look at what happens to the volume. Let's see. It says the diameter is decreased by a factor of 10. That means we're talking about length. Diameter is a length. So the length is always starts off as x, and it's decreased by a factor of 10. that means it's 1/10 of what it used to be. Okay, so the decrease by a factor of 10 means it's multiplied by 1/10. Okay, so if the original volume is x, the new volume is 1/10. I'm sorry. If the original length was x, the new length would be 1/10 x. Now, if we want to know what happens to the area and the volume, well, area starts off as x squared. So if I want to find the new area, I need to do 1/10 x, and I need to square that. Now, if I square 1/10, focus on the 10. 10 squared is 100. So this is going to be 1/100th x squared. Alright, so that tells us what happens to the area. The area decreases by a factor of 100. Let's see what happens with the volume. Well, the volume starts off as x to the third power. But to find the new volume, I need to take my new length. See how it all comes back to the length. The length gives us the area, and the length gives us the volume. But we always start from the length, which in this case is 1/10. So the new length is 1/10 x. But to find the new volume, we have to cube that. 10 to the third power is 1,000. So the new volume will be 1/1000th of the original volume. In other words, the new volume is decreased by a factor of 1,000. So, to answer the questions, they say how will it affect the circumference, how will it affect the surface area, and how will it affect the volume. Well, the circumference is still a length, just like diameter. So the diameter was decreased by a factor of 10. The circumference will be decreased by a factor of 10. So the circumference is decreased by a factor of 10, just like the diameter. The surface area is decreased by a factor of 100, which we see by what happens to the area. 100th of the original area, so that's decreased by a factor of 100. And the volume is decreased by a factor of 1,000. Looking right here tells us that 1/1000th of its original volume. This problem is relatively straightforward. This is half of a sphere, so if I want to find the surface area and the volume, I would just start by finding the whole surface area and volume, and then dividing that by 2, and that will be half of the surface area and volume. So the whole surface area is 4 pi times the radius squared, that's squared, and the radius we see is 4. So put that in your calculator. That's 64 pi. Okay, so half of the surface area should be half of that, so that should be 32 pi. And similarly, the whole volume is given by 4/3 pi times the radius cubed. Put that in your calculator. That turns out to be 128 pi over 3. Then half the volume, whoops, I messed that up. Back up. That was half the volume. Half the volume is 128 pi over 3. because the whole volume was 256 pi over 3. Okay, so these are the answers to the question right there. Okay, now number 7 is similar to what we've been doing with the length, area, and volume changes, but these are worded slightly differently. Instead of talking about doubling or tripling, they're talking about increasing by 20%. They're using percentages. So watch how we handle that. Watch for the similarities and differences. Let's see, a company makes a globe in the shape of a sphere. The company plans to make a new model globe with a diameter that's 20% larger. By what percent will the surface area increase compared to the original? Okay, now here's the key right here. Increasing something by 20% is the same thing as multiplying it by 1.20. Okay? That's the key. If I want to increase something by 20%, I multiply it by 1.20. I don't really need the extra 0. It'd be the same thing as multiplying by 1.2. If I wanted to, just as an example, if I wanted to increase something by 30%, then I would multiply by 1.30 or 1.3. Say if I wanted something to increase by 75%. Well, I would multiply by 1.75. Okay, so that's what's happening here. Okay, so let's apply that to this type of problem. So I want it to increase by 20%, so I'm going to multiply by 1.20. Now, we're talking about what happens when we increase length and then what happens to area. So let's do our normal calculations where we do length, area, and volume. I just always like to do them all. So if the original length was x, the new length is going to be 1.20 times x. And again, the 0.20 right here represents my 20% larger. Okay? So in sort of like this, the 1 represents one whole, the original whole, and the 0.20 represents the extra 20% that you're increasing by. So anyway, if I want to find the new area, alright, area is always length squared. But this time, my new length is 1.20 x. So if I want to find my new area, I need to square that. Again, we don't really need the 0, but I just want everyone to be able to follow easily. So just put 1.20 or 1.2 squared into your calculator without the x. If I do that, I get 1.44. So my new area is 1.44 x squared. Now, this multiplying by 1.44 is what percent increase? Well, I'm hoping that you can see that this represents a 44% increase. Okay? And since they're asking by what percent the surface area will increase compared to the original surface area, this 44% increase that we see right here, that is the answer to the question. So the answer is D. But just for the sake of completeness, they could have easily asked us what happens to the volume. So let's follow through and do that as well. The original volume would have been x cubed. So to find the new volume, we would do 1.20x cubed. Put that in your calculator. And I'm getting 1.728. Alright, of course, again, I did not put the x in my calculator. That would be silly. I just put 1.20 to the third power in my calculator, and that's how I got 1.728. Now, you have to be really careful about this. Does this mean that there was a 728% increase? No, it does not. When you read this, you're looking at these first two numbers right here. Okay, this extra 8 is a decimal. It's sort of like moving the decimal point twice. So please interpret this 728 as a 72.8% increase. Okay? If they had asked us what happens to the volume, then this is what we would have said. But they didn't, so we already have our answer. Okay, let's look at number 8. A sphere has a volume of this, 39 pi cubic centimeters. What is the surface area? If we are given a volume, we plug it into the volume formula. Volume of a sphere is 4/3 pi r cubed. This is the volume, so I plug it in right there. That tells me that 39 pi equals 4/3 pi r to the third power. Now, when I look at the answers among the multiple choices, I see that it's all decimals. So I don't need to worry about avoiding decimals. So I'm just going to go ahead and divide by 4/3 pi. So if I divide both sides by 4/3 pi, just like this. Alright, then that's going to cancel out the 4/3 pi over here. Now I could put all this in my calculator, and that's going to give me r to the third power. So let's put this in our calculator. I'm getting 117/4. Okay, well, I guess I don't need to have the decimals yet. Now, I'm going to go ahead and take the cube root of both sides to get my radius. Alright, so do this. We'll take the cube root of both sides, and let's put that in our calculator. One more time, remember to do cube root. First you type the 3, then you do second caret, and it becomes a cube root. So we're going to do 117/4. And that gives us this. We'll go with 3.08. We'll round it to, we'll use 2 decimal places for now. Okay, so we came up with a radius of 3.08. Okay, but remember, we are supposed to find the surface area. So we needed to find the radius so that we could find the surface area. So now the surface area is given by the formula 4 pi r squared. So we will take the radius that we just found and we will put it in right there. So this is going to be 4 pi times 3.08 squared. Okay, go ahead and put that in your calculator and see what we get. Actually, slow down. I'm looking more carefully at my answers over here, and I'm seeing, yes, there are decimals, but look at what's sneaking in here beside these numbers. Pi. Pi remains in all of these answers. So I do not want to put this entire expression into my calculator, because then that will get rid of the pi. I want to put everything except for pi into my calculator, for the 3.08 squared. In other words, type this into your calculator without the pi. Save pi for later, just like dessert. So that's giving us 37.95 if I rounded right there. 37.9 if I round right there. Okay, so this is 37.9 pi. Now if I take this and I compare it with my four answers over here, 38.0 is awfully close. So the difference between our answer and their answer is just probably a matter of where we rounded the r. They probably kept a bunch of decimal places instead of only 2. But we're plenty close enough to pick the answer as being C.